ပရိသတ်များအားလုံးပဲမင်္ဂလာပါရှင်ကျမတို့ရဲ့ Dr. Revo Group Channel လေးကနေမိဘပြည်သူများအတွက်ဘဝတူတာရစေမယ့်အကြောင်းအရာလေးတွေပုံမြင်ဇာတ်လမ်းကောင်းလေးတွေကိုရွေးချယ်တင်ဆက်ပေးနေတာဖြစ်ပါတယ်ရှင်ကျမတို့ရဲ့ Channel လေးဟာတော်လိုင်းရေးအမြန်ဆုံးအောင်မြင်ဖို့ရည်ရွယ်ကတည်ထောင်ထားတဲ့ Channel လေးဖြစ်တာကြောင့် Dr. Revo Group Channel လေးကိုနားဆင်ရင်တော်လိုင်းရေးနားဆင်ကြရင်ကျမတို့ရဲ့ Dr. Revo Group YouTube Channel ကို Like and Subscribe ပြုလုပ်ပေးကြဖို့မိဘပြည်သူများအားပေးနားဆင်ကြဖို့မေတ္တာရက်ခံအပ်ပါတယ်ရှင်
Guided missiles are effectively intelligent bombs. They track objects and even alter their course to hit targets with the precision of a surgical knife. While ballistic missiles simply follow an arcing trajectory their target, guided missiles relentlessly track and hunt their targets. Guided missile systems were first developed by the Germans during World War II. Germany's V-weapons program consisted of long-range tactical weapons that were fired into Britain and other cities in Europe during Hitler's air campaigns. Though the V-weapons were highly efficient at destroying targets in general, their automatic guidance system lacked the accuracy and precision needed to hit exactly where intended. The quest for precision and accuracy drove the engineering behind today's guided missiles, enabling engineers to create advanced systems that can be armed with a range of warheads and accurately hit targets more than 6,000 miles away. In fact, modern systems can even carry nuclear warheads to targets across the globe. But how do guided missiles operate with such deadly accuracy? All guided missiles are made up of several key components. These include the engine, warhead, flight control system, and guidance system. The engine propels the missile from the launcher to its target, while the warhead houses the explosives. The flight control system is responsible for maneuvering the missile and maintaining an accurate flight path, while the guidance system locates the target and guides the missile to it. The guidance system is arguably the most critical component of any missile. It allows the vehicle to reach its destination by combining target location information with navigation information. When it comes to missile guidance, there are 5 basic methods that came into use: command, inertial, active, semi-active, and passive. Many guided missiles use 2 guidance systems. One is built into the missile, while the other can be located at the launch station or far from the launch station in a central location. Command guidance systems track the missile from the launch site and transmit commands by radio, radar, or laser impulses. Today, a radar unit in the missile is often used to track the target and transmit bearing and velocity information to the command guidance system, where control systems compute the optimal trajectory and send commands back to the missile. Semi-active homing systems combine a passive radar receiver, which is located on the missile itself, with a separate targeting radar on an aircraft that illuminates the target, guiding the missile towards it. Since the launch aircraft has to keep moving towards the target to maintain radar and guidance lock, there's the potential that the aircraft will come within range of the enemy. Active guidance systems track targets with a radar transceiver that is contained in the missile itself. Since these systems don't require signals to be sent from the launch site, they make it more difficult for the enemy to locate the launch platform or aircraft that fired the missile. Passive guidance systems also don't emit energy or receive commands from an external source. Rather, they lock onto an emission coming from the target itself. Early iterations were primarily heat-seeking. Today, missiles can use other emissions, such as ultraviolet radiation. In inertial systems, missiles are programmed with predetermined flight paths. They use gyroscopic platforms and GPS to continuously determine the position of the missile in space. The guidance computers then combine the position information with velocity and direction information to generate commands that maintain the proper course. Such systems are advantageous because they don't include electronic emissions from the missile or launch platform, which could be picked up by the enemy. Target destruction. To find its target, the missile uses a terminal guidance system. The point of impact can be pre-programmed or use a digital scene batching area correlator system to find the target. Some guided missiles are also equipped with thermal imaging or illumination sensors. Once the missile hones in on the target, there are several methods that can be used to determine when it should explode. The first is on impact. In such instances, the warhead makes physical contact with the target and the explosive is detonated. Sometimes this method is combined with a slight delay so that the weapon detonates a specific amount of time after contact. A second method uses radar, sound waves, a magnetic sensor, or a laser to detonate the warhead when the target is within a specified distance. As technology continues to advance, we will likely have a variety of autonomous weapon systems that are able to identify, track, and neutralize enemy targets. Some of these systems may be housed in robots or drones, while others may even be based in space. If such systems do evolve, they will be more advanced iterations of the technologies that are employed in the current missile guidance systems.